Hello, everyone. Welcome back to SAT
Oh,
Math Question of WhatsApp. Hello. Welcome back to SAT Math Question of the Day. Let's get going. Here's the question. Please try it, pause it, come back, and we'll show you hopefully different ways to approach it. During her last road trip, Sophia drove. Oh, I don't have my annotation on. Sophia drove 402 miles on 12 gallons of gas. Sophia's car averages 37. I'm going to cross this out because I don't want to know what type of problem it is. Uh, Average 37 miles per gallon on highways and 25 miles per gallon in cities. Which of the following best approximates the number of city miles she drove in her car on this trip? Well, I need to reread this because I read it out loud. Weirdly, wasn't concentrating. Sophia drove 402 miles on 12 gallons of gas. Sophia's car averages 37 miles per gallon on highway and 25 in city. Which of the best approximates the number of city miles? Sophia's car averages on highways. Well, first of all, what is her? Just play with the problem. What is her miles per gallon on the trip? Just play with the problem. I don't quite understand it yet. 402 divided by 12 is 33 and a half. So it's in between, right?
no, I think my approach would be to express the facts in algebra
Yeah. Okay, that makes sense.
and, choose some, so we need to choose some unknowns, some variables.
Right. Yes. Yes.
And there's some choices of what variables to choose.
Right.
Clearly, the problem does not address the overall average miles per gallon over the whole trip.
Okay. So if you do X now, I already know this is a This is a linear equation algebra problem. So going in, I sort of knew that this was what the approach you would have to do. So these are the two unknowns: city miles, highway miles. We know that they add up to 402. So 402 is equal to x plus y. This is really number of. Okay, this is really number of highway miles. Okay. Now,
So we need another equation relating x and y.
right. Now, the amount of gas you use, is the number of city miles miles.
Well, okay, here we go. 12 is the number of gallons that was
Yes,
used altogether.
absolutely.
So what does 12 equal? It
Right.
equals the number of gallons used on the city plus, or in the city,
Right.
plus the number of gallons used on the highway.
Exactly.
Now, could you express the number of gallons used in the city in terms of the number of miles driven in the city?
Of course.
Well, there's a
Of
relationship
course there is.
because we're
Of
told
course there is.
the ratio of miles per gallon in the city.
Right. So,
So translate all that into algebra.
right. Miles per gallon. We know that there are 37 miles per gallon. So if you go,
Now, okay, good.
but it's 1 over 37. It's gallons per mile. So the ratio is 1 over 37. So it's 1.
Raphael, Joel, please write that more legibly.
I will. It's miles 37 is the highway, right? So that's y. So let's write it more legibly. Okay, fine. So what we're talking about here is miles per gallon. If you have 37 miles per gallon, then that's also equal to 1 gallon over 37 miles, right? So if you want to know, this is in the highway. So if you want to know how many gallons you go in the highway, then you multiply the number of, if you want to know, then you multiply by the number of miles on the highway, which is y. So using unit analysis, you have 1 gallon per 37 miles times y miles gives you, using unit analysis, gallons. So it's 1 over 37 plus 1 over 25x. You have to be very careful to make sure that you get the x and the y matched correctly with the 27 and the 37 and the 25.
So let me annotate this equation.
Right.
The 12 is the total gallons of gas used.
Exactly. Right. Yeah. So now we really do have.
And then let me finish. This term is this whole term is the number of gallons
on the highway
used.
So just say highway. Come on.
On
number
the
highway gallons.
Highway.
Okay.
We want to teach people to, the whole story.
Yes, I know, but we also want to get through the video.
No, we don't.
Yes.
And then the other term is the corresponding thing. The analogous.
Yeah, just say number of.
I'm writing it out.
The city gallons, number of city gallons.
Well, it's good to understand analogy. So
okay,
these two.
Fine.
This is the analogous thing.
Good.
For city.
Got it.
Driving.
Yep.
In particular, the number of gallons of gas used in the city.
Right. Okay. Bottom line is we have two equations, two unknowns. We have to solve them.
Yeah.
Notice this was a little hard. This one here, this 12 is y over 37 plus x over 25, was not that easy of a question to write, because normally you do the other way. You want to know how many.
Okay, so approach to SAT questions.
Yeah.
Sometimes you have to step away from thinking what is normally done.
Right, absolutely.
So we say normally it is. Really, the point is that you must be aware of different situations, right?
Right.
So that is a matter of awareness. Yeah. Now let's. So we got the two equations and two unknowns, but what does the question ask for?
Right. It asks for the number of city miles. We have to solve for x. The
number of city miles is x.
We have to solve for x.
So instead of solving for both x and y, what we should do is eliminate the y.
Of course, obviously. Of course. So maybe the best thing to do
is... It's not so obvious, because normally they ask you to solve two equations and two unknowns. Normally,
I don't know about that.
The goal is to give the values of both of the unknowns.
That's true, right? Well, that's
the question is asking for the value for only one of the unknowns.
That's right. So practicing enough SAT questions, knowing this is a predictable question, the way they ask it just solve for 1. So we only solve for x. So we have to say y is equal to 402 minus x. So then we shove the y in here, and we make that 402 minus x.
Okay.
Right?
Well, I have a better way.
Oh, so now we have to erase to make things clear.
Well, I have a better way of doing it. Take your equation, 12 equals 1/37th of y plus 1/25th of x. Multiply that equation by 37. And then subtract the resulting equation with the 402 equation.
That's not a bad way to do it. So we're talking about, okay, let's do that. Wait, that's so annoying. Okay, so we do 12 times 37. No rush to actually do that. Is equal to y plus 37 over 25x. And Seth is saying that you do y plus x and 402, right?
Yeah.
That's what you're saying to do, right?
Right. And then subtract the bottom of equation from the top equation.
Right.
And you really have a single equation for x.
And notice that when I'm doing it, I'm not in a rush to get the answer. I'm going to leave it as 12 times 37 minus 402 is equal to 37 over 25x minus 1x. Or x, 37 over 25 minus 1. Right?
Right.
So the answer is, again, sort of like going overboard about not doing any intermediate math, but leaving it at the end, is 12 times 37 minus 402 divided by 37 over 25 minus 1. That is the answer. Now let's bring in the calculator. Okay. What do you think of the idea of leaving all the calculations like that and not using intermediate math to get? What do you think of that? 12 times 37 minus 402. Okay, so that is equal to 42. Now, 37 divided by 25 minus 1 is a half. Okay, it's 0.48, but I'm just going to say a half. So this is 84. Right? It came out to be 0.48, okay? Came out to be 0.48. So fine. People with a calculator, it's 42 over 0.428. It's 42 over 0.48. Okay. 42 divided by 0.48, which we know is 87.5. But at this point, as soon as you see 42 over 0.48, you just make it a half, and you know that this is 84. For those who wouldn't, okay? That's a faster way to 84, approximately 84, that's the answer. But yeah, if you have a calculator, just do 0.42 over 0.48 directly. So that's it. So that was a really good idea to use. Elimination rather than substitution here.
Yeah.
Yeah. That was a really good idea. Yeah. That's just that this is a sort of a scary equation because you got fractions. But yes, if you just multiply by 37, you turn it into a y. Yeah, that was a really good idea to do. So, Yeah, this was not an easy two equation two unknown problem because this equation is a little unusual, and as Seth said, you got to be ready for the unusual on the SAT.
Okay. I wonder if there's here's another approach. Stemming from your first stab, you calculate the average, which I said was irrelevant.
That's right.
But maybe it is relevant. You calculate the average of the whole trip, right?
Right.
And then you see, is it closer to 25 or to 37?
Exactly. That's how you could check. It's using intuition.
And then if it's closer to 37, it meant she drove more on the highway.
That's right.
If it's closer to 25, it's she drove more in the city.
That's right.
And the question is, there are two reasonable choices.
Yep.
The 87 and a half and 314 and a half.
That's right.
And notice that those two choices add up to 402.
Yeah.
So I
Yeah.
wonder how we'll fare by using, this method. So, calculate 402 divided by 12.
So I'm going to clear this, okay? Yeah, we know it's 33.
All right. It's 33. So it's closer. So the average miles per gallon, the average fuel usage is closer to the highway usage. Therefore, she drove most of the trip on the highway. So, which leads us to answer D.
C, because they want the city.
Oh, okay. Yeah. So
words,
she drove more on the highway, therefore less on the city. Okay.
Mostly highway, right?
Yeah.
So I was set while you were doing this problem, as you were talking about it. I said to myself, we could check to see if the answer makes sense using this analysis.
Yeah. Oh, yeah.
And the thing is, it does make sense using this analysis. The question is, who has the guts to use this analysis and use intuition and sort of like using this analysis and throw away the actual answer and throw away the way to actually do it specifically. This is not a bad way to do it, is to think sensibly. Again, it's very rare to see on the SAT that you actually have to solve an actual full set of two equation to unknown problem. However, on the digital side, that's right, we're on the digital side. We've seen this. We've seen that on the digital side, you may actually have to solve a full-blown two equation to unknown problem. But yeah, this is a really, really, really good way to do it, is to just take the average and see that it's closest to 37, which means it has to be more on highway, which are the only two that makes any sense to be more on highway, because these numbers are sort of ridiculous based on miles as she drives. And these numbers are not that far from each other, right? 37 and 25 there. Yes,
well, the distractors, the A-B distractors are the corresponding numbers of gallons used on the
okay.
Used in the city and the highway.
Yeah.
And so if you make the mistake of confusing the numbers of gallons with the numbers of miles,
yeah,
you'd be led to picking one of those.
So yeah, it's really interesting. You absolutely can do it this way because the answers are far apart. This is a really good way to do it. It's very useful to know both ways, and to be good in both ways is to know how to solve full equation to unknown, and also be more of an intuitive approach. I guarantee you they did not use this approach in doing it. So let's see how they did it. Plus, today's Throwback Thursday, so we have to leave some time for doing a Throwback Thursday question. So we clear all drawings. We say this is the answer. Okay, and now let's see how they answered it. Too bad they don't give multiple approaches. 6 steps. You know you're in trouble. Let's start by defining some variables. That's what Seth was very... That's exactly what... Oh. Amount of gas. Wait. H is... That's what we did. Didn't we do X was mine?
You did. No, they did.
Oh, they
took. Okay. Well, when setting up in this problem, there are 2 choices for what the variables.
Yes.
What variables
there
to use.
are.
The choice we used was numbers of miles.
Right.
The choice they used was numbers of gallons, used in the city and on the highway.
Right. So if you do number of gallons, the equations are easier
Yeah.
because you don't have that weird fraction, which you go back to the video, you see sort of stumped me because you had to use unit analysis to make sure you got that equation right. Here, you don't have a fractional equation, so the equation is actually easier to set up, and it's much more intuitive.
Yeah, so they got the same. They got the same equations.
No,
Well,
no,
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 they didn't
no.
get. They no, again, C and X, right?
Yeah,
They are related by the fuel economy ratio.
right. Yes,
Yeah.
yes, yeah. It's essentially the same, except here you don't have fractions. We
Yeah.
had fractions, and our equation was harder to set up because you had to think more about exactly how to write it. They did gallons, and then we know that the number of gallons that you use is the number of miles times the miles per gallon. Um, yeah, so their equations were easier to set up, but they had to pay for it at the end because the final answer was not in the answer they wanted. They wanted to know the number of miles, not the number of gallons. So you have to then convert. You have to then convert knowing that they wanted city, right? They
Yeah.
want knowing that they got the number of city gallons, but they didn't ask for the number of city gallons. They asked for the city miles, and then you have to do the final conversion at the end. So somewhere you have to do the conversion, whether you do
Mm.
it before or after. Notice they do not show the intuitive approach of saying, "Hey, you could double check your work by seeing if this makes sense," which is too bad. But yeah. So yeah, I mean, Seth said initially, right? Figure out what you need to solve for. That's why I chose the variable x was the number of city miles directly, because that gives you the direct answer. So anyway, any other thoughts on before we move to Throwback Thursday?
No.
Okay. Okay. So again, we try to offer different approaches. Um, so let's do Throwback Thursday. This is our Throwback Thursday question, which was chosen a few weeks ago. Uh, oh, okay. Okay, here we are. Oops, gotta clear this. Gotta clear annotation, clear all drawings. Okay, here we are. Throwback Thursday question. This is a question from the SAT book from about 20 years ago, from the early 2000s, 2000 and something, 2001 or 1999. And it has a whole different feel to it, but it's not. Possibly you could see this type of question in the modern SAT post 2016. Okay, in the figure above, the radius of the circle with center S is twice the radius of the circle with center O, and the measure of RST. So this one is bigger. This one is bigger by 2. The angle is bigger by 2. Okay. If the area of the shaded region of circle O is 3, then what is the area of the shaded region of S? Well, we know that if you double the radius, you multiply, if you multiply 2 on the radius, then it multiplies 4 or 2 squared on the area. So immediately you know that this is immediately 12 based on the radius, based on the doubling of the radius. So it's equal to 12 based on doubling the radius.
That's because the area is multiplied. The area of 3 gets multiplied by 4. And that's because you multiply the radius by 2, which multiplies areas by 2 squared.
That's right. Whatever ratio you multiply the scale factor of the dimension, the area gets multiplied by the square of the scale factor. Okay, so that takes care of that. Now we have to do with the angle. So if you double the angle, does that double the area? You think intuitively it would. But yeah, it does. Yeah, it does. Yeah, if you double the angle, yeah, it's sort of like it's very, almost obvious, right? If you double the angle, then you double the area. So that means this would be a 24. Now we double 12 to get 24.
Well, a rigorous mathematical argument is that when you double the angle, what you do is you add a copy of the angle
Yeah.
add a copy of the segment, and the area of the seg it's the area of the segment or sector. I think it's sector. The area of the sector with the double angle is equal to the area of the original sector plus the area of the copy,
Right.
which is the same area, and so the enlarged sector has double the area.
Right.
Yeah.
So, yeah, I mean, in this question, I think we talked about it the other day, the difference between completely understanding something from fundamental principles and just sort of knowing what to do in a
Yeah.
specific situation. In this
Yeah.
situation, if you double the dimension of a geometric figure and the surface area, the area doubles and the volume, no, the area
Yeah.
goes up by the square of that factor and the volume goes up by the cube. Just,
Yeah.
it really makes sense just to know that rather than have to derive that from scratch every time.
Mm.
Um, and you people, I'm sure most people have seen this in geometry class. It's really helpful just to know that. Cold going into the SAT. Um, so, I mean, Seth, we'll go in. Maybe now we'll finally do our introduction. Seth is a PhD in math from MIT and Professor Emeritus in Computer Science from University of Albany. I have a PhD in Mechanical Engineering, and we are here to hopefully show you how to approach studying for the Math SAT and different approaches to doing the Math SAT questions in terms of studying for the Math SAT. Go to Khan Academy, take the course on either digital or not digital, and do all the questions because Khan Academy partners with the SAT people. So there's a pretty good correlation between what the Khan Academy questions are and what you actually will see on the SAT. In terms of approaching the problems, it's what we do. We try to offer different approaches on how to do the problems and give some insight. Sometimes very theoretical, sometimes very practical. What is Seth doing? Seth's playing games. But in terms of the sometimes people do find it confusing about this concept of if you have a scale factor and you double the size of something, the area doubles and the area goes up by the square of the scale factor, and the volume goes up by the cube of the scale factor.
Yeah.
Just know.
Yeah. Well,
Just
well,
know.
the game I was playing
Yeah.
is uh, illustrates the game I was playing is the an approach that's developed in calculus,
Okay.
where the area of the sector is approximately, and then in calculus is actually equal in the limit to the sum of areas of little skinny sectors.
That's right. Right.
Right? And so the area of the whole thing is equal to the sum of the areas of the little skinny sectors that are approximately little skinny triangles.
Right.
And so this is the intuition that's developed in calculus for why the area of a sector is proportional to the measure of the angle.
Right. Right.
And so if you double the angle of a sector, you double the area.
Right.
And
Yeah.
similarly, if you halve the angle, you halve the area.
Right.
If you triple the angle, you triple the area.
Right. That all makes sense. That all makes sense.
You multiply the angle by 5. However, there's a weird thing that happens with circles. If you multiply an angle if you multiply an angle a lot, you might get an angle that's bigger than 360 degrees.
Yeah.
And then the figure spanned by the angle covers parts of the circle multiple times. So what would the area be?
What? I don't know.
Like here it goes. Suppose you have, half a circle, which is, a sector of angle 180 degrees. If you double the angle, what you do is you have a sector that spans the whole circle. But what if you triple the angle?
Yeah, but once you go above 360, you go back on itself.
Yeah, yeah,
You're so on a tangent.
yeah.
Why don't we
So
just?
when you deal with angle multiplying, you have to angle addition is a weird thing that happens when the angle exceeds 360
Right.
degrees.
Yeah. Yeah.
You would make it equal,
Right.
considered equal to the angle obtained by subtracting off from that
Right.
big 1 360-degree angle, subtract off 360.
But it has to do with cycles anyway. Same thing with the day. You're right. If you add 27 hours to the day, the day restarts again.
Not really, but if you let's say it's a difference of what you're solving for. If you say you're 6 o'clock, 6 p.m. 6 p.m. today, 24 hours later, it's 6 p.m. tomorrow.
Right. Yeah.
But the amount of time is 24.
Yeah.
24 hours. If you add to 6 p.m. 36 hours, that's a day and a half.
Right. Yeah.
Right? Then you get to 6 a.m. The 2 days in the future. So if you add 36 hours in terms of getting the hour, the hour of the day, adding 36 is the same as adding 12.
Okay.
But in terms of counting the number of hours between now and then, you add 36.
Okay, look. This, everybody, I love Seth, but just forget what he said.
I said it because I want you to remember. Don't forget what I said.
No, but it's so
It'll make me feel unhappy.
I'm sorry. That was really, I shouldn't have said that. But let's move to something that can actually, that really is important, because we all know that if you go over the cycles on its own. But this shows you, this is something that really is really important for the SAT and for generally for geometry. This shows you that if you double the radius, you multiply the factor of the area by the square of that doubling. Okay, see A0, you make a little r here and you make a big R here. Big R is twice little r. So if you substitute big R into this equation and square it, you get 4r squared. But this little r here is the same as this r here. So you can see that the area of circle S is 4 times this area. This is the area of little a0. See that? See how we did that analysis? This is really important to see. This is going deeper in terms of just memorizing what I've said. It's not a bad thing to memorize. Okay, this explains why what we said about you double the area, you do the square of you double the radius, you do the square of the area. You double the radius, you do the square. Double the radius, you do 2 squared to get the area. This really explains what's going on. Okay, so this is how you do the analysis if you don't remember the relationship. Okay, substitute. Okay, so I'm sorry. I don't know how. Yes, you're right. When you have an angle greater than 360, you double back on yourself. So you do have to be careful. You have to use it.
Okay.
Okay, I think we are done, right?
We are done.
We are done. Please like us, dislike us, send us comments on our YouTube videos. And if you have any SAT math questions, email them to us at satmathquestion@gmail.com. See you tomorrow.
Okay, bye.
Bye.